We've done some previous work on limits, and when you're asked to find the limit as x approaches 0 of a quotient where you've got two functions, we'll call them f of x and g of x, and if that happens to be 0 over 0, it's difficult to find the limit. Now, it may be useful to be able to use Taylor's polynomial as approximation for these, and then to actually use that to calculate the limit. So if we have these two functions and when we put x equals 0, we get 0 over 0, we can use sometimes Taylor's polynomial. Alright, so how does that work? So say we've got, for example, we've got to find the limit as x approaches 0 of sine x over x. Now if we put x equals 0, sine of 0 is 0, and if we put x equals 0 there, so we get 0 over 0, so therefore this is indeed a case where we may be able to use Taylor's. Now, by Taylor's polynomial, sine x is approximately equal to x minus 1/6 x cubed plus 1 over 120 x to the power of 5. Now that was done in previous work. Sine of x is approximately equal to that polynomial. So therefore we can say that the limit as x approaches 0 of sine x on x is equal to the limit as x approaches 0. Instead of sine x, I'll put x minus 1/6 x to the 3 plus 1 on 120 x to the 5 all over x. How does that help us? Well, we can't substitute in x because we'll still get 0 over 0, but there is a factor of x on the top here, so that'll be the limit as x approaches 0 of x outside of 1 minus 1/6 x squared plus 1 on 120 x to the power of 4 all over x. Now because that x is connected to the bracket by a multiply, I can cancel those. And that's 1 and that's 1. So now that we've got no divisibility by 0, we can put x equals 0, so we don't write limit now that we're doing the substitution, and you get 1 minus 0 plus 0, which is equal to 1. So there's one very simple use of using Taylor's polynomial to actually find and evaluate a limit. That will also work with cos x. Also, when you've got limits where cos x involve an e to the x, so something to keep in mind.